Now let's have a look at a past HSC question. In my last video I mentioned that many HSC questions are based on application of series concepts rather than the process. So this is from 2007, question 7. Back in 2007 there were no multiple choice questions and there were 10 questions, so question 7 would be sitting around the middle, not too hard, but definitely not one of the process questions that appears at the beginning of the paper. So let's read the question. Heather decides to swim every day to improve her fitness level. On the first day, she swims 750 meters. And on each day after that, she swims 100 meters more than the previous day. That is, she swims 850 meters on the second day, 950 on the third, and so on. So hopefully you can see straight away that this is an arithmetic series with the first term being 750 and the common difference being 100. Part 1, write down the formula for the distance she swims on the nth day. Now if I look at the mark, it's only worth 1 mark. I mentioned that if the question doesn't tell you it's an arithmetic series, you need to show that. And if they expect you to show that, there should be a mark associated with it. So if this part was a 2-mark question, then I would do a show and then I would go and find the formula. But since it's only worth 1 mark and there is a single answer that's required, there doesn't seem to be a need to show that the series obtained is arithmetic. Despite that, I think it's good practice and good mathematics to make a statement saying that this is an arithmetic series and so on, therefore. So let's read the rest of the questions and then start. How far does she swim on the 10th day? So based on the formula from part 1, we want to find the 10th term. What is the total distance she swims in the first 10 days? So there's a sum question. After how many days does the total distance she has swum equal the width of the English Channel, which is a distance of 34 kilometers? So looks like another sum question, but they've given the final sum and we want to work out the number of terms. Again, with all these application questions, the idea is to take a real-life situation and convert it to our basic mathematics so that we can use the rules we've learned to solve the problem. So we go from word problem to mathematical problem and then back to producing a word solution. So, part 1. Let's establish a series. Day 1, day 2, day 3, and so on. So this is an arithmetic series with a equals 750, d equals 100. I'm not going to prove it because there is no mark associated for it, but I need to state where I get my formula from. So Tn is a plus n minus 1 d, and they want an equation, specifically write down the formula for the distance she swims on the nth day. Well, let's, instead of Tn, write day n, 750 plus n minus 1, and the difference is 100. If I simplify that, that becomes 650 plus 100 n. So there's my answer to part 1. Part 2. How far does she swim on the 10th day? So day 10, 650 plus 100 times 10. So that would be 1,650 meters. Now the first part asks for a formula. Well, I've got that. The second was a sentence question. How far does she swim? So they've asked the question, so we need to provide an answer. She swims 1,650 meters on the 10th day. Part 3. What is the total distance she swims in the first 10 days? So formula for sum n on 2. Since we've got the last term, we can use n on 2, first plus last. So sum of 10. I'm just going to do 10 divided by 2 straight out. My first term, 750. My last term, 1,650. We calculate that, which gives me a total of 12,000 meters or 12 kilometers. So, using the words of the question, what is the total distance she swims in the first 10 days? Okay, last part, part 4. After how many days does the total distance she has swum equal 34 kilometers? So now they've given me Sn is 34 kilometers or 34,000 meters, and they're asking me to find n. Now I don't have the last term in this case, so I need to use the formula 2a plus n minus 1d. Let's substitute everything in. Okay, need to do some algebra. Take the 2 to the other side, or we can multiply the 2 within the bracket. Rearrange, we'll end up with a quadratic formula, and we have to solve the quadratic formula. Okay, so expanding this, I'll end up with 700n and 50n squared. So I've got my 50n squared, my 700n minus 34,000, dividing by 50, and then factorizing results in n plus 34 and minus 20. So I get two n values. N equals negative 34 and n equals 20. But n is the number of days, so negative 34 doesn't make sense. Since n is positive, then n must be 20. We have to finish with the sentence because we need to answer the question, and the question said, how many days does it take for her total swim to be 34 kilometers? So therefore, that's a good example of application of arithmetic series. Next, we're going to look at a few of the geometric series applications.